This is lesson 1-4, angle measures, and we're going to talk first about what a ray is, which you have seen before. So a ray, like the sun's ray, goes from the sun, and then outward, and then it goes on forever. So let's go ahead and name this one M, P, and so this would be either ray, MP, or we would put an MP with a ray up above it, just like we've been used to seeing with lines or line segments. Now we do have something called opposite rays, so that's where they have a meeting point in the middle, and that is going one direction this way and the other direction this way. And I'm going to go ahead and put H here and K here, and I'm going to go ahead and name these JH and JK. Ray JH and ray JK are opposite rays. So we name them separately because they are two opposite rays. So I don't know, maybe it might help to see. There we go, two different colors, but having that common endpoint. So common endpoint. So an angle is formed by two non-collinear rays that have a common endpoint. So here's their common endpoint, and there's their rays. This would be the interior, and this would be the exterior. This is called the vertex. So R is its vertex point, that common endpoint. So we can name this by its number or by the three letters, so SRT. And we use this angle symbol in front of it to let us know that it is an angle. So that's very important that we use this angle symbol in front of our naming. So we could name this angle SRT, or angle 1, or angle TRS if we wanted to go this direction, but R is always in the middle because it's our vertex. So let's go ahead and practice using some naming with this example, this map here. We're going to name all the angles that have K as the vertex. So here is K. So we have this angle here, HKJ, which we could name JKH, but we're going to go ahead and just for now name it that. We could also have this angle here, so we could name it JKC. And those would be the two that have that vertex point. So if we name JKH, it's the same angle as this. What is the name of the sides of angle 6? So here is angle 6 right here. Go ahead and get my stuff out of the way there. So this right here is angle 6. What are the sides? So here's one side and here's one side, and those are rays. So we have ray, JK, and we have ray KC. Or sorry, it's KJ. We want to go from the center out, especially with our ray symbol there. So KJ, since we're going from the end point out. There's our kind of arrow if we're referring to angle 6. All right, what's another name for angle AJK? So let's find AJK. So this angle right here, well, 9, angle 9, would be another name for that angle. Name a point that's in the interior of ECG. So ECG. So name a point. Well, this point is in the interior, and that would be point D. Put the point or say point D. So down here, if you want to try these two on your own, go for it. Pause the video, try them. If not, you can follow along as we name the sides of angle 5 here, which would be BG, and BE, this side right here. You could also name B it BF if you wanted to stretch it. It's all the way, since F is a point, you could name it BF, and that would be the same as BE, or the same side as you're referring to. What's another name for angle 7? So we could have this angle ABD. Start on the outside, go to the vertex, and then back to the other outside point. Now we're going to practice using our protractor. So our protractor measures angles. We're going to look at 3 types that you've seen before: a right angle, which is 90, an acute angle, which is less than 90, and an obtuse, which is greater than 90. So we do need to make sure that flat part is on one ray, and then we'll measure where the other ray is at. So for here, I don't really have my measurements within this, so I'm just going to go ahead and kind of tell you. But TYV is going to be this angle right here, which if we measured it, we would find out that it is 90. So I'm going to go ahead and put kind of a little right angle there. So 90, so it is right. Next we're going to look at is WYT. So this angle right here, which we can see is obtuse and greater than 90, and it is, if we measured it, 130. This next one, TYU, so I'm going to get rid of this stuff so we can see TYU. Here's T, here's Y, here's U. So it's this angle right there. So that's acute. And if we measured it, we'd get 45 degrees. And on the last one, SYX, is this angle right here. And that is obtuse, and it measures 135 degrees. Now, the other thing that angles may have is what we call arc marks. And arc marks just mean that they are congruent. So congruent angles have the same measure. So these would be equal in their measurement. So we would read this as the measure, the M stands for measure, of angle ABC is equal to the measure of angle DEF. We only use the M when we're talking about, and the equal sign when we're talking about measure. Equal signs goes with measure of actual values. We use congruent when we're talking about the figures, that this angle is congruent. ABC is congruent to angle DEF. Angles have the same measure if and only if the angles are congruent. Okay. A ray that divides an angle into 2 congruent angles is called an angle bisector. So it's bisecting that angle into 2 congruent angles, basically cutting it in half. Okay, so a bisector is turning it into 2 equal angles. So we're going to take a look at some examples of that. So here we have some angles that are marked here. This one plus this one is equal to the total. So that's our angle addition postulate, just like segment addition. This angle plus this angle can equal the total. So let's practice a couple of these examples. It helps to label our figure as we go. So ABD right here is congruent to FHG, this one right here. So it helps to put arc marks as kind of our markings to show that this is congruent to this. Now, ABD, it's given us a measure. Let's go ahead and put that in there. 3x plus 6. Then it gives us FHG, so I'm going to go ahead and put that in there. Now, find the measure of ABD and find the measure of FHG, the ones they just gave us. Well, if we know that they are congruent, then we know that they are equal. Okay, so we can go ahead and set 3x plus 6 equal to x plus 26 and solve. So 2x plus 6 is equal to 26, subtract 6. So 2x is equal to 20, which means x is 10, but they don't want x, they want these angles. So we have to plug 10 back in. So that's 3 times 10 plus 6, which is 36. And then we have 10 plus 26, which is 36, which it should be because they should both be equal, which they are, 36. So in this next example, we want to label what they give us here, and then we're going to find angle DEG. So first, DEF, this angle is 48 degrees. FEG, right here, is 67 degrees. We want to find DEG. Well, that's the total. So that's going to be 48 plus 67, which is going to give us 115 degrees for our angle DEG. So an angle bisector we kind of talked about is bisecting this into two congruent angles. So if that's the case, then we know that angle LJK is congruent to angle KJM. So let's go ahead and take a look at some examples where it talks about bisecting. Bisecting means that this is equal to this. So we can put those arc marks and then let's fill in what they give us. This would be 4x plus 6, and this would be 7x minus 12, and we know these are congruent, so we can go ahead and set them equal to each other. And then we can go ahead and solve. So 6 is equal to 3x minus 12. We're going to add 12. And we get 18 is equal to 3x. So we know that x is 6, but that's not what it's asking. It's asking what is angle JKM. Well, JKM was 4 times x plus 6. So we're going to plug the x back in and solve. So we get 30 degrees, which we know that that's also this angle, but they just want that one. So try B on your own and see how you do. If you don't know where to start by labeling what information they give you, knowing that this bisects tells you that this angle is equal to this angle, and try it. If you don't know what you're doing, then let's go ahead and do it together. PQS, it does not give us, it wants us to find that. It does give us it does give us PQS. We're finding PQR. So PQS is right here, this angle right here, and so that's 5y minus 1. Then it gives us the PQR. That's the whole angle right here. So I'm going to just kind of show you. That's all this angle right here is 8y plus 12. So we kind of know the total. Now, if this is 5y minus 1, and these have arc marks to show that they're congruent because they bisect, wouldn't this be 5y minus 1 too? So you can go ahead and fill in if you don't already have something, if it bisects. So that means that 5y minus 1 plus 5y minus 1, the two angles, equal our total, which is 8y plus 12. So that's going to give us 10y minus 2 is equal to 8y plus 12. And then we're going to subtract 8y. So we get 2y minus 2 is equal to 12. Add 2, and 2y is equal to 14, which when we divide by 2, we get y is 7. But that's not what they want. They want us to find PQS. So we're going to plug it back in for PQS, which is 5 times 7 minus 1, which ends up giving us 35 minus 1, or 34 degrees.